Hi class, welcome back to my YouTube channel, and for today's class, we are going to discuss general mathematics, which is lesson 15, solving exponential equations and inequalities. So from our previous lesson, we discussed and defined these exponential equations and inequalities. So for today, we are going to discuss the different steps and we'll give some examples how to solve exponential equations and inequalities. So in solving exponential inequalities, we have to remember this statement. So in solving exponential inequalities, if the both sides of an inequality are multiplied or divided by the same negative real number, then the inequality symbol sign must be changed. So this is a concept of your inequality equations and inequality given inequalities. If you have need to change the sign by dividing or multiplying both sides of the inequalities to a negative number, real number, then you must change the inequality symbol. So now let's discuss how to solve inequality for exponential function. So we have here the properties first to be considered. So first, if the base, or denoted as b, is greater than 1, then our b raised to x is greater than b raised to y. If and only if your exponents, which are x and y, so the x is greater than to y, and your b raised to x is less than to b raised to y, if and only if your exponents x is less than to the y. So that is the first property that we must consider. So second, if your b or the base is in between 0 to 1, or b is less than 0 and is greater than 0 rather and less than to 1. So example values of b is 0.1, 0.2, 1/2, 1/4, and so on. Then your b raised to x is greater than to b raised to y, if and only if your x is less than to y. And your b raised to x is less than to b raised to y, if and only if the exponent's x is greater than to y. So if the range are if your base is in between 0 to 1, then you need to interchange the inequality symbol. So now let's discuss the steps to solve an exponential inequality. Again, I have 3 here. So first, rewrite the equation so that the bases are the same number. So just like in solving exponential equation, we need to make sure that you have same bases to be able to easily equate your exponents. Next step, we have to apply the property of inequality for exponential functions. So this time we need to simplify and apply the properties we have in inequality for exponential function that we discussed earlier. Then solve for the value of x. And last step, we have to check your solutions. You may choose any value of x that is within the interval. So you need to choose one. You can choose one to be able to check your solution. So now let's have examples in solving exponential inequalities. So now let's have example number 1. Solve 3 raised to x less than 81. So first step in solving this exponential inequality, we have to rewrite the equation so that they will have the same bases. So both sides should have same bases. So we have 3x less than 81. So this 81 can be written as 3 raised to 4. So 3 times 3, that is 9, times 3, that is 27, times 3, that is equals to 89. So this inequality can be written, equation can be written as 3 raised to x less than 2, 3 raised to 4. So this time, they have the same bases. In getting the proper base, you must see first the base of one side. So if they can be raised or multiplied to itself for how many times, then you will accumulate the value in your other side, then you can make use that base. So now for the second step, we need to apply the property of inequality for exponential functions and then solve. So since we have now same bases, we can now get our exponents. So we have here to our left side x, then less than 4. So that is x less than to 4. This will be now the solution set to the inequality. So this is the simplified one. So your x is less than to 4. So the solution set to the inequality is x is an element of real number such that your x is less than to 4. So to solve, to check if this solution set is correct, is your solution set, let's substitute one value from this interval. So let's have less than to 4. So let's have x equals to 2. So let's substitute x equals to 2 since 2 is less than to 4. So 3 squared less than 281. So 3 times 3, that is 9. So that is less than 281. So meaning this statement is correct. So this interval or this solution set is also correct. So the solution set for 3 raised to x less than 81 is x is less than to 4. Yeah. X is an element of real number such that your x is less than to 4. Let's have another example. Example 2, we need to solve 2 raised to x plus 2 greater than to 1 over 32. So this time we have this fraction to our right side and then base, which is 2, to the left side. So first step in our solution, we need to rewrite the inequality, the equation, so that they will have the same bases. So we have 2 as the base here. What value or what we can make use this 2 as your base for this right side. So how? This is 1 over 32, meaning you have 1 over 2 times 2 times 2 times 2 times 2. So that is 5. So 2 raised to 5, that is equals to 32. So we can write this exponential inequality with 2 raised to x plus 2 is copy the left side. So we have greater than as the symbol. So we have now 2 raised to negative 5. Why do we have negative 5? So that the law that we apply here is negative exponent, the negative law of exponent. So since we have 1 over 32, so 32 is still 2 raised to 5, so that is equals to 2 raised to negative 5. So second step, we need to get the exponents and apply the property of inequality. So we have x plus 2 greater than negative 5. So simplifying this equations, we have x greater than negative 5 minus 2. So we subtract negative 2 to both sides. So we'll have x plus 2 minus 2, that is plus 2 minus 2, that is 0. So we don't have a constant here, so that we have x we just have x, then greater than negative 5 minus 2. Or simply we transpose this positive 2 to the right side and change the sign. And our x now is greater than to negative 7. So negative 5 minus 2, that is negative 7. The solution set to the inequality is x is an element of real number such that your x is greater than to negative 7. What are those values? So part of your interval will be negative 6, negative 5, negative 4, negative 3, 2, 1, up to positive 0, up to positive values. So those are part of the interval. So let's make use x equals to 0 to check to substitute in your exponential inequality to check if this solution set is correct. So x equals to 0, 0 is greater than negative 7. So we can make use of that. So substituting 0, we have 2 raised to 0 plus 2 greater than 1 over 32. So 0 plus 2, that is 2. So 2 squared is greater than 1 over 32. Let's check if this is correct. So 2 squared is equals to 4. So 4 is greater than 1 over 32. So this statement is correct, meaning our solution set is correct. So let's have a last example. So example 3, we have solve 5 raised to x minus 1 less than or equal 625. So first step, we need to rewrite our inequality equation. So we have 5 here as your base to the left side. So we can make use that base and find the exponent, right exponent, to get a value of 625. So 5, we can make use 5 raised to 4 because that is also equals to 625 because 5 times 5, that is 25, times 5 for the third time, that is 125, and times 5, 125 times 5, that is 625. So we have 4. You multiply 4 times the 5 to itself. So we have 5 raised to x minus 1, then less than or equal to 5 raised to 4. So second step, we need to equate our exponents. So x minus 1 less than or equal to 4. So since they are the same bases, again, let's just equate our exponents. So simplifying this inequality, we have x minus 1. Let's just add 1 to both sides. So we will have x minus 1 plus 1, then less than or equal to 4 plus 1. So we will have x less than or equal to 4 plus 1, or simply transpose negative 1 to the right side, that will be positive 1. So our x now is less than or equal to 5. So the solution set to our given inequality is x is an element of real number such that your x should be less than or equal to 5. So to check this solution set, let's substitute a value from this interval. So let's make use positive 4. So x equals to 4, that is less than to 5. So let's substitute 5 raised to 4 minus 1 less than or equal to 625. So 5 raised to 4 minus 1, that is equals to 5 raised to 3. So 5 raised to 3 is equals to 125. So it is less than to 625. So this is correct. This statement is correct. That means the solution set that we got to the step 2 is correct. So that's it for solving exponential inequality.